Okay, so a few things that are going to be happening in the class. Okay, first off, we have survived our first 6 weeks of the school year. So now it's like I typically like to say you want to be focused on the big picture because it's the 3 6 weeks grades that are going to determine your semester grade. And you've already got the first one locked in. Okay, so we still have plenty of time for both the second and the third 6 weeks to maybe get those grades up a little bit if yours was a little lower than you would like. In fact, I believe in all classes but one, I did have some folks who were failing. Okay, so if you're in that situation, the second and third 6 weeks are now even more important to you. And the first thing I have on the board, all these items that we're going to talk about, waivers are going to be due to, I believe her name is Marcia Edwards, Mr. Young's secretary, by 10 a.m. on Friday. If anybody in this class or a weighted class happen to have failed the first 6 weeks, you can get a waiver to still participate in whatever activity it is that you are a part of. But remember, it's only one waiver per class per year. So if you want to go ahead and use a waiver for this class, you cannot use a waiver in this class the entire rest of the year. So just kind of think about that. Tornado drill is going to happen on Thursday at 9:15 a.m. So that's going to be happening during your second period class. But let's talk about it real fast. In case there would be severe weather, or we had a tornado or something, where do we go? We are going to get to the main hallway. So normally, if it's a fire drill, we go right out this door, down the stairs, past the nurse's office, out to the sidewalk, where in a real situation, buses would be waiting to take us to a secure location because we don't want to stand next to a burning building. But if there's severe weather, we don't want to go outside. We want to stay inside. So when we get down to the first floor, in fact, right below us is the 1200 hallway. We're going to go right down this hallway below us, past these computer classrooms, to the main hallway of the building. In fact, right down at the end of the hallway, where the main hallway and the 1200 intersect, there's the art office right there on the corner, right across from those vending machines. Okay, right there in the main hallway, that corner is where we want to meet. Okay. So that's what's going to be happening on Thursday, wherever you happen to be in your second period class, but that's for us. And, just a couple things I know. You're probably going to run into some of your friends, but we really want to try to keep you as quiet as possible. We want you to face the wall. We need a path in the middle of the hallway, so an administrator, a teacher, in case he or she needs to go ahead and give you instructions, can easily make it up and down the hallway, tell you what's going on. Try to stay off your cell phones, your social media, all that good stuff. It's just a drill, but that's happening on Thursday. Any questions on what we would do in here? Everybody knows where we would meet? Okay. Let's see. This Thursday, we're also going to have our first quiz of the 6 weeks, and it's going to cover inverses. Okay, so you want to be looking ahead to that. I should be able to get you your papers you turned in today back to you tomorrow. You can use those as a resource. You also have your notes. Only a handful of people have actually come to me, downloaded the McGraw-Hill app, and downloaded the digital textbook. If anybody's interested, you can get a whole resource of problems, explanations, all kinds of good stuff. Okay, just download the McGraw-Hill app, come talk to me, I'll get your name in the system, you should be good to go. Okay, but that quiz is coming up on Thursday, and we are a couple of weeks out, but it's still not too early to go ahead and start mentioning this to you so that you can begin to prepare ahead of time. 2 weeks from today, on Monday, October 8th, is your first exam of the 6 weeks. And by that time, we will be into trigonometry. So we definitely want to be looking at all that stuff. In fact, before the end of the week, we should already be in that. Okay, talking about definitions and kind of setting the foundation for everything we're going to do. Now, that's going to be an interesting week because what's happening on the 10th? That's the PSAT, so I don't even believe I'm going to see you guys that day. So more than likely, after we take the test on Monday, the 8th, Tuesday is going to be like a review reteach day for anybody who wants to talk about the exam. We'll go over it, any questions, and then we'll kind of see what happens. I'm definitely not going to assign any homework prior to the PSAT, but depending on how much time we have, we may or may not go ahead and start the next lesson because I won't see you again until that Thursday. So we'll kind of see how that works out. Any questions on the board listings I have? Okay. And the fun continues because being the first week of the 6 weeks, they've asked that we go over the beginning of the year expectations again. All right, so I know it's a little monotonous. You guys have heard this in your other classes, but I was given until Friday to cover this with you guys again. So let's just go ahead and talk about them. If you have any questions, please let me know. All right. You guys have been doing a really good job, but there are a few things I would like to see start changing for the second 6 weeks as we move forward. Our goal is to create a school that is safe, friendly, and where students learn at high levels. Okay, you always want to wear your spurs. Self-esteem, positive attitude, unity, respect, and support. Okay, your spurs can impact your academics, relationships, and your school. Okay. Ways that wearing our spurs keeps us safe, friendly, and learning at school. Okay, we'll follow staff directions, be kind to others, take care of the school and the classroom, only bring to school what you need for learning, okay, and your cell phone. Use technology only for assignments, keep yourself and others safe. All right, so, it's just like I always say, treat others as you want to be treated. Okay. Just try to represent your school in the best light. What might happen if you don't wear your spurs? Okay, so these are consequences for failing to meet the expectations that we have. A warning, a side conversation with the teacher, move to refocus zone. Okay, and I'll go ahead and let you guys take a look at those. And of course, they do escalate depending on the severity of whatever occurred. What happens if you get caught wearing your spurs? Tickets are passed out to redeem a prize. I don't believe that has started yet. Is that right? Okay, first period actually asked me to talk to an administrator about that to see if they were going to begin that at some point. So I've got a note written. I'll ask about that. The rest of these, coupons for a snack, special privileges, pocket points for classrooms, teacher recognition, those are more in-class items. But first 6 weeks, I mean, we are all extremely busy, myself included. I wasn't even really thinking about that stuff. I'll try to take some time this 6 weeks to see if maybe we could do something like that, kind of see if that would motivate some folks. Here are alpha principals. So hopefully at this point you know who your alpha principal is based on your last name. And of course, Mr. Young is our building principal. The bell schedule, I don't think anybody's having any issues with that. The first couple of weeks in fifth period, dismissal for lunch, 2/5, and so forth, I think was a little hectic. But I think everybody's good with the schedule now, right? No questions on that? Okay. See, we're moving through this very quickly, nicely. ID badges, okay. It's really a security and a safety measure. We need to know who belongs on campus and who does not. That's why when I'm out in the hallway, I'm always asking folks, even the ones who completely ignore me and just keep walking past, when I ask them to wear their badges. So if anybody in here does not have your badge on right now, please put it on. If you don't have your badge, I'll need you to run down to the office and grab one. Okay, you got to wear your badge. And it's one of the things I see throughout the years. People are hooking them to their backpacks, and then they just have them kind of slung over your shoulder. You have to wear them around your neck, guys. Okay, you can't have it hooked to your backpack because when you get in the classroom, you still have to wear those. Okay, it's just one of those expectations. What if you forget or lose your badge? The temporaries, the stickers are $2, replacements are $5, and they can be purchased before school in the main office. Okay. The cell phone policy, you guys have done really well about this, in class, when we go ahead and start our discussions, our lectures, as long as, even mine goes off from time to time, that's not a concern. You just make sure it's off your desk so it's not a distraction. We don't want to be under the desk texting how cool math is. You can do that later. Okay. But if it does happen to be picked up, and last week was the first time I had to do this, if I take it up, you're not getting it back at the end of class. Okay, I'm going to take it to the office, and then you're going to have to follow the policy. So if your parent picks it up, that's going to be free. If you go pick it up, that's going to be $15. And I wouldn't want to be put in a position where I would have to pay to get my property back. So, please just keep those out of sight. Okay, there's a time and a place, and we don't need to worry about that right now. And then, of course, it escalates as the problem continues. All right. LISD policy regarding harassment and bullying. Lubbock ISD and Lubbock High School prohibit bullying and cyberbullying as defined by state law. Okay, so you can see our definition there. Again, what I'm going to say about this, if you or someone you know is in this situation, please speak up. Okay, maybe that person doesn't want to speak for him or herself, but be that person's voice. Because if nobody is made aware, nothing can be done about the problem. Okay, talk to a teacher that you trust, an administrator, maybe some other kind of trusted adult, or even if you just want to remain anonymous and you just want to talk and call to somebody, occasionally we all just want to vent and get things off our chest. 806-370-3558. Okay, that is available. If you need the number, come talk to me and I can get it to you. All right. Now, there is one change. You've probably started seeing these posters around the campus. I've got mine over here by the door. It's so colorful. I'm hoping that it's one of those things that kind of catches your eye as you walk out. Has it been effective? Has anybody seen it? Few folks. Hey, well, okay, some people are shaking their head no. Well, I'm glad I'm pointing it out. Be smart online and using digital tools. So, safe, meeting, accepting, reliable, tell, smart. Safe. I will be safe by not sharing my personal information with anyone online, such as name, school name, phone number, home address, and or photos. Meeting. I will be careful and not meet face-to-face with people I have encountered online because I know this can be dangerous. And you hear stories about that all the time, okay? Just please be careful. Be careful, okay? Especially when sharing your personal information. Just don't do it. Accepting. I will check to see who is sending emails, instant messages, links, and pictures before clicking on or opening anything sent to me because I realize it can contain viruses or inappropriate messages. Even our email, what's the term used nowadays? Catfishing? We get emails occasionally where if we're not really paying attention and we click on them, our computers are going to be infected with some kind of virus. A couple of years ago, it got pretty bad because one spread throughout the system. So we actually have a department now. We can send the email to them and they can inspect it if we suspect that it may be doing something like that. Reliable. I will check information before believing things posted online to make sure it is factual. Okay, verify it instead of just continuing to spread it. It's like gossip. And tell. I will tell someone I trust if anyone makes me feel uncomfortable or if someone I know is being bullied online. Okay. The thing about this, I would never say, don't. You should be able to take pictures with your friends. You should be able to share them, be on social media. Right, Jacob? Right. Okay. That's open. Okay. But just be smart about what you do because as you get older, those things can and will come back to revisit you. In fact, as you're getting older, you're going to start looking for a job. You're going to start putting in applications. And a lot of the bigger companies nowadays have divisions where people are solely dedicated to looking you up on the internet. They go through Twitter. They go through Facebook. And if anything compromising pops up, that can cost you your job. It can cost you a promotion. They're referring to it nowadays as the digital tattoo because once it's on the internet, it's pretty impossible to remove. You may go ahead and take down the posting yourself, but once it's been shared, once it's out there, somebody's going to have a copy of it. It's always out there. So just please, please be careful about that. Okay, especially in the culture we have nowadays. I mean, how often is it happening? It's almost like a weekly occurrence that somebody in the news is getting in trouble because of something that they posted or said 10 years ago, 15 years ago. It does happen. Okay, so just please, please be careful about that. Building procedures, hallway expectations, walk and talk, walk on the right side of the hall, PDA free zone. What's PDA stand for? Public displays of affection. I know you're young and in love, but there's a time and a place for it. It is not here. We don't want to see that. Okay, if my wife were to walk in, you would not want me and her, you don't want to see that. It's gross. I don't want to see that by the same token. Okay, so this one always makes me laugh, electronic free zone, because you see these posters around electronic free zone and people just walk past them with every type of technology that we have available nowadays. But there are certain things, one bud in, one out. In fact, today I've come across 4 different people who have both earbuds in. I said, excuse me, sir. Sir, and I actually have to walk up and tap them on the shoulder because they can't hear me. And that's just really a safety issue, because if something were to happen and we're like, hey, maybe there's a lockdown, we need to get in the classroom now. Hey, sir, hey, hey. And the guy's just, not listening because he's listening to whatever, you guys like to listen to nowadays, whatever it is. Okay, so just have one earbud out so we can still hear. As far as the technology, you can be on your phone. This is what an administrator told me. You can be texting on your phone, you can be listening to music on your phone, but you cannot be making a phone call on your phone. So you can't use the device for what it was originally intended in the hallway. That's the one thing we do want to go ahead and stop. So if you have one of those earbuds, I mean, unless we're paying real close attention, we're not going to be able to tell anyways. But if you've got it up to your ear, that's kind of an obvious clue that you're talking on your phone. So, just kind of be mindful of that. That's what the administration wants us to let you know. Extra stair locations, that's not going to really apply to us. We already know in case of a fire drill or a severe weather where to go. We just recently talked about the severe weather. Library expectations, sign in upon entry, be courteous, wear your ID badge, work quietly, come with a pass from the teacher if coming from a class. Okay. Again, wear your badge. They're very stylish. Okay. See, I got mine all covered in all kinds of bling. Yeah. It's cool. Okay. But yeah, you got to wear your badge. Sorry about that. Off-campus expectations. So whether, you're just going down the street maybe to a restaurant, or even if you're going to a game, you just want to make sure that you represent LHS in the best light, because you don't want people to start thinking about LHS in a negative way because a group of people did something that they shouldn't have. Wear your spurs, Okay, and I think this is, again, referring more to, like I said, football games, kind of school activities, things of that nature. And here you're expected to be in the bleacher sections. You may go to the concession stand and return immediately to the bleachers. Loitering in the concession area is prohibited. Earlier classes were telling me that at a previous game, students got out a beach ball that was confiscated. Is that right? Okay. So personally, I don't see what a problem is with a beach ball, but I guess it depends on what people were doing with the beach ball. I don't know. That's the last one as far as beginning of the year expectations. You should be hearing about these again in your other core classes, because all of them were asked this week by Friday to go ahead and cover those with you again. And you guys are doing a great job. As far as my personal expectations, okay, I think you're doing a really great job. I think a lot of people who were absent, though, I think could really benefit from going to the website. I think that's probably the biggest concern that I would personally see, because somebody who's gone like 2 or 3 days, they come up, okay, I need you to give me all the notes and everything that I missed. And remember, it does not work that way. Okay, over here on the door, if there are any extra copies of what I passed out that day, they're going to be over here, okay, on the day that I passed them out. And if it's not there, that means I've run out of copies. Okay, but that does not mean you shouldn't go to the website. It has the videos, it has the notes, it has everything you need. So the idea is to go to the website, at least look over the notes if you're not going to sit and watch the video, so that when you come in for tutorials, okay, I can help you out. Because if you miss 3 or 4 days and you come in for tutorials and you're like, okay, it's 7:45. We have 20 minutes for you to go ahead and teach me everything I missed in the past 4 days. It is not going to happen. Okay, it just does not work that way, especially if there's multiple people in there, because I'm going to try to get to as many people as I can. So I'm really going to emphasize the website. Again, be going to the website. We're in the second 6 weeks, and if you're not aware of the website, or if you're not visiting the website, then at this point, that's on you. Okay, that is your decision not to go to the website, so it will affect your grade. So you just got to think about that. You got to stay on top of things. Okay. Questions? Okay, a lot of information. For what? It was not. No, that was off the document they provided us for students who should be logging onto the system. No, my birthday's in January, so. Okay. Anywhere from 1 to 31.
Yeah, but like,
Why?
that's, maybe we might have like the same birthday,
You're in January too?
for sure.
Okay, what's your day?
Class first.
I know, but I asked you second.
Okay, one's bigger than two.
One's bigger than two?
Yeah, for sure. Like if you're in a race, you're ahead.
I
But one's bigger
like that. I'll tell you, it's later in the month. There you go. All right. Anything else? Any questions pertinent to the expectations we covered? Okay. So we're good? All right. So a lot of information today. All right. And now, finally, we can get to some math. I know that's what you've been waiting for this whole day. Okay. This is actually going to be a calculus lesson. I'm going to be talking to you about the difference quotient. So anybody who is planning on going into calculus next year, this is absolutely something that you are going to be seeing again, and you are going to be doing a lot with it. Now, this is the universal method. This formula is going to find what we call the derivative of a function. Yes, there are shortcuts, but I'm not going to be talking about those shortcuts with you. I'm going to be talking about the difference quotient right here. Okay, and in fact, we get to do our first proof today. I'm going to show you how we derive this. So this formula computes the slope of a secant line through 2 points on the graph of f. Well, first, when I say secant line, how many points of intersection am I referring to? Graphically, how many points of intersection for a secant line? Maybe think back to geometry. 2, there we go. 2 points of intersection. Now, what the derivative is going to help me find is the slope of a tangent line, which only has 1 point of intersection. All right. Now, the one thing that you're going to do in calculus, I'm going to show you here for our very first example, but you're not going to be required to do this in here for what we're doing. We're simply going to work with the formula. Once you've simplified the formula, then you'd go ahead and take the limit as h approaches 0 of f of x. The result is the derivative. Okay, so let's talk about how we get this formula to begin with. So let's say I have my first quadrant here, okay, just a grid, and I have maybe some kind of curved graph like this. Let's call him function f. Okay. And let's say I want to go ahead and take some arbitrary value of x here on the axis. Okay. Well, what would be the corresponding y value? What kind of notation do we like to use? Well, we use interval notation when describing the intervals, but I'm talking about what kind of notation that would refer to my element, the elements in my range, the y values. And just think about the process. We have the function and we substitute in a value of x. I'm even giving you half the name when I say notation. It starts with an F. Function notation, there we go. So this ordered pair would be described using x, the value on the x-axis, and then f of x. Because the equation of the function, I would substitute x in, and I would get some kind of corresponding value of y out of it. So x, f of x. Okay, well, let's say further on down the axis, I go ahead and choose another value of x, but this is where the h that you keep seeing over and over again comes in. H is going to represent the horizontal distance between the values of h that I'm choosing. So this value right here would be x plus h. So whatever two values of x I'm choosing on the x-axis, I'm saying that h is the horizontal distance between them. Okay? Whatever number of units that happens to be. So now, like if x, okay, yields the point x, f of x, what point would correspond with x plus h? Okay, heard a couple people say it. So this would be x plus h. Okay, there's my x value, the input, and then f of x plus h. Because if I wanted to know the corresponding y value at x plus h, then I would take x plus h and substitute it into my function. Simplify, and I'd get a y value out of it. Okay, well, what's really interesting about this is that the biggest idea in calculus, this idea of a derivative, is based on the simplest idea in algebra. Because these 2 points, I'm going to go ahead and put a line through them. This is the secant line that we were talking about. It's got the 2 points of intersection, right? Well, the derivative is going to help me find the slope of a tangent line, 1 point of intersection. And in order to do that, I need to find the slope of the secant first. So that's the change in y over the change in x. Remember the rise over the run? Okay. So let's take these 2 points that we created, and let's go ahead and find the slope. So I'm going to take the difference of the y's first. So I'm going to say f of x plus h minus f of x all over. Then what would I put for the denominator? X plus h minus x. There we go. And what do you notice in the denominator? Yeah, x minus x are going to cancel out. So the result is f of x plus h minus f of x all over h. There's our difference quotient. That's the formula we're going to use. This is the universal way of doing it. Okay, whether it's just a normal everyday function or you even start to involve trigonometry, whatever. Okay, like I said, there are shortcuts, but I'm not going to cover those in here. I'm going to let Mr. Heinrich take care of those next year. Now, let's go ahead and talk about very quickly why we take the limit as h approaches 0. Look at the graph for just a second. This point right here, the one represented by x plus h, f of x plus h, imagine that it were tangible, that I could actually grab it. I could grab that point and I just start sliding him along the function until the 2 points come together. Okay. Well, if I were to start doing that, what would happen to h? Yeah, the distance between them would decrease. It would get smaller. Or as we say, it would approach 0. Okay, until we get to that 1 point where you no longer have a secant line, you have a tangent line. Okay, 1 point of intersection. All right. And we want to know what the slope, the rise over run of that tangent line is. Because here's the thing. When we're talking about slope, okay, slope at this location, whatever I have, is going to be different, okay, from the slope here. It's not like a linear function. It's not going to be constant. Because it has a curve, the slope is constantly changing, right? We refer to this as instantaneous rate of change. So the derivative is going to allow me to find the slope at any specific value of x that I want. Okay? Any questions so far? Now, I'm going to go ahead and run through a full example, and you'll notice the first example I have on your paper is this quadratic right here, right? 3x squared minus 5x plus 4. That one's rather large. I'm going to start with one a lot smaller, more basic. Okay, just to make sure you kind of get the idea. So if you want to put this somewhere on your paper, let me erase this real fast. Okay. And based on what you just saw, I'm going to go ahead and use the quadratic parent. So let's say f of x is equal to x squared. This is the first equation that I'm going to apply the difference quotient to. Okay, just as a very simple example to kind of set the stage. Now, x squared is going to look like this. Here's our parabola. You know, he goes through the origin, 0, 0. There's f. Okay. Now, how many people in here have had experience before with derivatives? Okay, so Satish, let me go ahead and start with you. I've got x squared. Can you tell me what the derivative would be? It is simply 2x. That's right. So that's our prediction. He is telling me that our derivative, and this is how we can denote it, you'd use just a little tick mark. We say prime. So f prime, the derivative, we're saying is 2x. So by applying the difference quotient, that's what we should be getting. Okay, but there is going to be a difference what we're doing in here and what you guys are going to be doing in calculus. Okay, so let me first write out my difference quotient. It's f of x plus h minus f of x all divided by h. Okay. Now the numerator has 2 parts to this. Okay, the first part is represented by f of x plus h. Whatever function I'm wanting to take the derivative of, every x that I see, I'm going to replace that x with x plus h. So instead of x squared, Okay, here's my fraction. I'm going to put in x plus h squared minus. Now the second part of the numerator, I simply want to subtract the function I'm working with itself. I'm working with x squared. That is f of x. So I'm just going to subtract x squared. So if you take a look, this first part, this represents the f of x plus h minus, and there's just f of x. Because the one thing, if anything, that usually tends to confuse people when we first start doing this is how to apply the formula to your function. You first want to substitute x plus h for every x you have, and then you simply subtract the function itself. And all this, of course, is going over what? H. My denominator is always h. Okay. Now, once you've successfully plugged in, this is just normal algebra. So I'm going to expand, distributive property, like terms, all that good stuff. So we've talked about this before. What would x plus h squared give me if I were to expand it? X squared plus what? There is an xh term, but what's the coefficient? 2. You remember that little rhyme? You square the left, you square the right, double the middle. That means multiply the two terms together, x times h, and then double that. So plus 2xh, and then plus h squared. Okay, so that is x plus h expanded, okay, minus the x squared all over h. Well, what do you notice? Okay, the x squareds cancel, x squared minus x squared, so they're gone. Now, all we have left to do is just simplify any h's that I can. See, I've got 2xh plus h squared over h, so I can say 2xh over h plus h squared over h. Well, those cancel here. What's h squared over h? That's just going to be h. So 2x plus h. Now, what we're going to do in here, that will be your answer. Okay? We will not be taking the limit as h approaches 0. You're going to take that idea and carry it when you get to calculus. Our goal is simply to work with the formula. Okay? Now, I am going to go ahead and continue it like you will in calculus, but for what we're going to be doing, your answers on your homework, that's as far as you're going to go. Everybody's okay with that? Okay. So now let's say we do go ahead and take the limit as h approaches 0 of 2x plus h. Well, what's happening to h? You told me just a few moments ago he's what? He's getting smaller, right? He's just going to continually get smaller and smaller until eventually he's so small, well, he has no effect on anything that's left. So basically, any term or h that remains is going to disappear. Okay? Now remember, what did Satish say that the derivative was when we first started? 2x. What did we end up with? 2x. Now that is what I would use to find the slope of any tangent line on this graph that I want. And there's going to be a lot of tangent lines. Like I could have a tangent line here, here, here. I mean, anywhere around, I could continually just be touching it in one point at any time, right? But let's go ahead and focus on a specific one. Okay, let's say I want the slope of this line right here, this tangent line, but let's say this is when x equals 2. See, because the slope is constantly changing, you have to have a specific value of x to know what the slope is at that location. Well, we got 2x, right? So what's 2 times 2? 4. So the slope of this line would be 4. Okay. Let's say I wanted to know what's the slope of the tangent line when x is negative 3. Imagine it touches. Well, can anybody tell me real fast what would that be slope be? Oh, negative 6. I take the negative 3 and plug it in the derivative. So this would be -6. And that makes sense because the line is dropping to the right, correct? Now, there are real-world applications, but this is what we're going to be focusing on. Okay? All right. Thank you guys very much. You have a great day. I will see you tomorrow.